research project uh, uh, with the title of Study of Dielectric Strength on the Blends of Mineral and Natural Ester Insulating Oil. I am Shahrin Abdul Ghani. I'm from University Technical Malaysia, Malacca. So in terms of background of research, so basically we in this what we call in the high voltage application, especially in the power transformer, most of the time the mineral insulating oil have been used due to its availability, low cost, excellent function dielectrics, and good long-term performance. Okay, but there is some issues which is known as it is non-renewable substance, and it might having this kind of run out in the future. Therefore, in this current situation, there is a needs of using this kind of natural ester insulating oil. This kind of oil is originate from vegetable oil. Okay, so it is originated from renewable source which offer fire safety, excellent biodegradability, and low sensitivity on moisture effects. But natural ester NEI oil has low oxidation stability, and due to its nature, from this kind of vegetable application or renewable sources, the cost to earn this thing is quite high. Therefore, our project is going to apply this kind of blended oil, which combination between mineral and natural ester oil. This kind of approach that could contribute in terms of benefiting dielectric strength, aim to reduce the usage of mineral insulating oil, and at the same time to enhance the properties of both insulating oil by taking into account the pros and cons between this MI oil and natural ester oil. So the objective of this research project is to investigate the dielectric strength of this oil. Okay, so basically we try to produce three types of sample, which is first the mineral insulating oil itself, the natural ester itself, and also the blending of the mineral and natural ester oil through this dielectric strength measurement, which is known as AC breakdown voltage measurement. In terms of literature review, so this is the what we call the research progress that we can see from 2013 until 2016, where we can see there is a trend of study in terms of mineral and blending between mineral and natural ester oil. So this study is going to investigate the potential of this blended insulating oil in terms of dielectric strength. So this is our method. So first one in the preparation, so the oil storage, do the filtering process, moisture treatment, moisture check, and we do the blending process. Same goes to our blending insulating oil, where we can see that the first we focus on the measuring the oil percentage, the blending process. We focus on the storage itself. We want to control the effect of moisture, and then do moisture treatment, and also we do the breakdown testing. So this is the mixing ratios of the mineral insulating oil and natural ester oil blends. So we produce almost 11 samples, where sample 1 and sample 11 are the 100% of this mineral insulating oil, and in sample 11 is the 100% of NEI oil. And sample number 2 until 10 is the variation of the composition between mineral and natural ester oil. So we look all of the aspect with the highest of mineral oil and until the highest of the natural ester oil itself. So at the left side is the AC breakdown voltage test for AC breakdown voltage by using Mega OTS 60PB in our lab, so that we comply with the standard ASTM D1816. Okay. So this is our result. Okay, where we can see that in the figure itself is the photograph of the prepared sample. So for the first, on the left side is the pure 100% of mineral insulating oil. In the middle is the blending of oil. Okay, so at the left, at the right side is the pure natural ester oil. So based on this, we can see that even after we do the blending, okay, by referring to the center of the photograph, the center of the samples, you can see that nothing changed, okay, in terms of a physical observation. Okay, this is our result in terms of breakdown voltage or the dielectric strength measurement. So based on this, based on our methods, we have prepared 11 samples. So starting from number 1, okay, so number 1 samples is the pure 100% of oil. So we can see that it produced almost in average 24 kilovolt breakdown voltage, and number 11 is the pure natural ester oil, is around 34 kilovolt oil. So in order to do the blending, so we can refer samples from number 2 until 10. Okay, between the samples, samples number 2 until 6 is the ratio where we can see our mineral insulating oils are having composition more than 50%. Otherwise, in sample 7 until 10 is where our mineral insulating oil is having less than 50% of composition. So to be more practical, in order we try to stick to have in order to analyze, we try to focus on the composition of the oil, of the mineral oil, of which not less than 50%. So that's why we focus on samples number 2 until 6. So in that sample number 2 until 6, the highest breakdown voltage value is come from samples 3 and 4. This samples 3 is the composition of the mineral insulating oil is 80%, whilst the natural ester is 20%. On the other hand, if you look on the samples number 4, which produce the same result, around 28 kilovolt, both of it in sample number 4, the mineral insulating oil is 70%, whilst the natural ester is 30%. So based on this, we can conclude that the AC breakdown voltage, the best blending mineral insulating and natural ester insulating oils is for sample 4 and 3. Okay, so which means that all of these are having more than 50% of the mineral insulating oil, because we don't want to reduce too much. That's why we normalize to have our mineral oil more than 50%. So from there, we can see that the highest breakdown voltage comes from this sample 3 and 4. Okay, so for further research, we plan to observe this blending sample, this blended samples effects in terms of physical-chemical properties, durability tests, and compatibility tests. So this is our reference, and thank you very much.